All right, we're going to go ahead and touch on how to pause a process. So first you would need to find the process ID. So we can use ps-ef and pipe that to grep to find the process name. Then to pause it, we would do kill-stop process ID. Then to restart it, we do kill-continue process ID. Okay. Now keep in mind you have to be root to manipulate processes you don't own. So let's go and go to our virtual box here. I'm going to clear my screen. I'm going to sudo up to root. Alright. Now I'm going to do sleep 60. I'm going to throw that in the background. Okay. I'm going to do a ps-ef pipe grep sleep. And there you go. You see I have the sleep command running. Okay. We're going to go ahead and use this guy right here. This one. Okay. So we're going to do kill-stop. Make sure it's all capital when you type it. And we're going to use the process ID, which is going to be this guy. And there you go. You see it stopped. Now if we want to resume that, we do kill continue process ID again. 2402. And then if I do jobs, there you go. You see it's running again. Okay, so that's how you would pause it and then continue it again. So back to our PowerPoint. Move on to the next slide in concept, which is going to be the time and date. Now guys, I'm just going to very briefly touch on this. This is kind of a Unix thing, but K-shell has a special parameter which is seconds, which always contains the number of seconds since the epoch. Evaluating the seconds variable at the beginning and end of the job gives you the start and end times, and the difference is the elapsed time. Unix doesn't take leap seconds into account. A day in Unix time is always exactly 84,000 seconds. Therefore, time of day arithmetic on Unix time is easy. So we see the start time, which is seconds, the end time, which is seconds, and the elapsed time is going to be end minus start, which we just talked about here. So we do a printf of the process completed, and we do the dot day, and then we minus that from the elapsed time. We do the day and the seconds. Okay, we're going to get this output here. Guys, don't worry about this too much. Just know that there are ways to see when commands ran and for how long. And this is how we would do it. Speaking of time, though, let's talk about scheduling execution. So the tool for this is cron, and every user has their own cron tab to schedule recurring jobs. So to list what cron jobs are currently available or are set up, we would do cron tab -L. And to edit the cron tab, we would do cron tab -E. You can do a man on the cron tab to find the syntax and configuration for cron. We can also, if I go to my virtual box here, you can also do a cat /cron tab. There we go. And you see it'll give you the setup here. Okay. You see we actually have some things set up here. Move my screen down a little bit. There are actually some cron jobs running. We can see those here. All right. So all these guys here are different cron jobs. So we see the user, okay, and then the command or script to be run. Clear my screen, and we'll head back to the PowerPoint. So there's actually another form or way we can set up jobs to be run. That's the @ command. So we can use the @ command to execute commands at a later time. The @ utility shall read commands from standard input and group them together as an @ job to be executed at a later time. Usually @ is installed by default in Ubuntu. If it's not, guys, you can use this right here. We'll do sudo apt-get install @. In my case, @ is set up. Here's a sample way to run a job. So we can do @ now plus 8 hours -f for file, and then run the script myscript.sh. @ is very laid back, guys. There's a lot of different ways we can run @. We could even just type in @ and we'll get a We can do it at, I could even say like t time, at t time. And then you notice it opens up a little prompt for apt, and I could say run the ls command, run the top command, and echo finished. And then done. Oops. And then I would hit Control D to finish that. And you see here, job 2 is going to run Tuesday, September 15th at 1600, which is 4 o'clock or tea time. I can also do at now plus 8 hours, just like it said. And so do echo hello. It's in 8 hours. There you go. Oops. I see, because it's trying to look at that as a command. Okay, if I had a script to run though, I could put it here. I don't have any scripts that I like to run, but you see from the example, this is kind of how we set that up. So we could set it up as a one-liner, or we can even just do at the time, and then put all the different commands that we want to run at that specific time. So that's handy. If you're running a one-off, maybe you want to run something just one time, you would use the at command. If you want something to run on a regular basis, you're going to want to put it in the cron tab. Aliases are another useful feature. So the corn shell or POSIX shell allows you to create aliases, customized commands. The alias command defines a word of the form name equals string as an alias. When you use an alias as the first word of a command line, the corn shell checks to see if it is already processing an alias with the same name. If it is, the corn shell does not replace the alias name. If an alias with the same name is not already being processed, the corn shell replaces the alias name by the value of the alias. So we can use the alias command to create, list, and export aliases. We can use the unalias command to remove aliases. So guys, a quick example of that would be, let's say that you get tired of typing in, power off. Maybe you just want to say off. Okay, so I could say alias off equals power off. And then when I type in off, it's going to relay that to the power off command. It's just going to turn my machine off. Okay, so that's how alias is kind of best used. It's for when you, maybe you don't want to use certain commands. Maybe you remember them better as a different word, so you can set up a different word to run the commands. Okay, another example of that is I could do alias search equals grep. Okay, so maybe you have a tough time remembering grep, and maybe you just want to say, hey, search. Okay, I'm not going to do that because I like using grep. That's kind of how it works. So if I type off right now, it would actually turn off my machine. I don't want to do that though. I want to keep it on for right now. Maybe I'll show you later when we finish these PowerPoints. So we're going to talk about how to find shell commands. So FC stands for either find command or fix command. For example, list last 10 commands to enter, FC-L10. FC-L10. And there you go, it lists the last 10 jobs run. Or, I'm sorry, commands run. And then we also can list the commands through a specific range, so we could do 130 through 150. Okay. Obviously, I haven't run that many commands on here, so it's not going to list that. But maybe I can do like 2 and 5. And there you go, it lists commands 2 through 5 that have been run on here. Okay. You can also list by a certain phrase, such as SSH, which is going to list all commands since the last command beginning with SSH. I haven't done any SSH, I don't think, on here, so we probably won't see any for that. And -L stands for list, guys. Yeah, see, I haven't run any commands with SSH, that's why I won't find it. You can even edit commands using the VI text editor. So we could do -E for edit, VI, and then 1 through 5. So I could do a FC, -E for edit, VI, 1 and 5. There you go. I can even edit these commands here in the VI editor. Okay. Another useful way to check up previous commands is the history command. Almost all modern shells allows you to search command history if enabled by user. User history command display the history list with line numbers. Lines listed with a star have been modified by user. So type history at your shell prompt and check out what it does. Let me clear my screen real quick. So if I do history, it's going to pull up all the commands I run, which you can see here. Okay. Another useful thing is if I type bang bang or exclamation point, and then a number, oops, there we go, it will actually run that command again. So if I do 178 here, so I do exclamation point, 178, it's going to run that sleep 60 ampersand symbol command again. Okay, let me clear my screen. There you see the sleep command running again. Okay? Or around that command in the background again. So another useful way to check up previous commands. So in summary, guys, we talked about process priority, background job, signals, traps, debug and exit, K-shell coprocessing, bash coprocessing, pausing, time and date, scheduling execution, run commands later, aliases, and how the shell finds commands, and command history and editing. Next session, we're going to talk about shell programming language, reserved words, how to write and run scripts, debugging, data types, using variables, the typeset command, constants, special predefined variables, printing to the screen using echo and print, the printf command, accepting input with K-shell, accepting input with bash, arithmetic operators, floating point numbers, bitwise operators, grouping operations, binary, octal, and hexadecimal, indexed arrays, quoting, and command substitution. If you guys need a little bit of extra help, follow these links for weekly and monthly plans for private tutoring sessions for system administrator management, as well as private tutoring sessions for Linux and bash scripting. Thanks for joining me, guys. I'm looking forward to seeing you in our next session.